Hello and welcome to today's video. So on the workbench today is the power controller, and I'm working on the firmware. You can see I've got on the debugger, it's plugged in. I've been testing all the hardware out on it, and we got the IGBTs going, the IGBT drivers, the photovoltaic gate drivers putting out 10.5 volts. Those guys are coming on. I can measure across there. I can see the resistor, so that looks good. Contactors are working, and we'll flip that one on, and I got this other one hooked up. Unit ID, that's pretty simple to read. The blinky light's all working, so it looks like all the hardware is working that I've tested so far. I haven't done the CAN bus yet. I was working on the A to D converter and doing the analog section. There's an 8-volt linear regulator on the back side that powers the current sensor board, and when I flipped that on, the magic smoke came out of the op amp on the current sensor board, which is unfortunate. Apparently, I made a mistake in the schematic, and that carried over to layout, which is unfortunate because I actually built up all of them. So if we take a gander over the schematic for it, so that current sensor is plus and minus 225 volts. Power it with 8 volts. It needs between 6 and 12, and 8 volts is convenient because, you know, it just works out nice for the math. This ratio metric output ends up being 4 volts, and then it goes plus or minus 2 volts around that 4 volts. So I go through a little bit of a low-pass filter, voltage follower, and then we hit the, this is a gain with level shift, and puts us around, so 2.5 volts ends up being 0 amps, because my board is expecting 0 to 5 full scale, where 5 volts is equivalent to 250 amps, and 0 volts is equivalent to negative 250 amps. So because my sensor can only do plus or minus 225, I've kind of scaled it back a little bit. So I can still read this 0.2 volts above and below, so if something went bad with sensor and it connected to ground or something with the op amp or connected to 5 volts, then we definitely know that something is wrong with the current sensor. So that works out pretty good. But if you haven't spotted the problem yet, I like to have, when I do my op amps, I like to have the feedback coming over the top. That's just how I've always drawn them, kind of used to that. Ultium's default op amp has the positive and negative terminals swapped. So what I did is I flipped it I flipped it this way when I drew it so that I could have that, and I forgot to go back and change pin 4 and 8. So essentially what I'm doing is right now I'm putting 8 volts on the ground, and the ground pin is connected to 8 volts. So ground to 8 volts and 8 volts to ground. It doesn't like that. It lets the magic smoke out. So yeah, I'm going to have to redo these boards. Even had extras, but they're not too big, so it's not going to be too bad. I'll probably just hit fix it and then hit OSH Park. Yeah, you know, but I wanted to make sure that the design actually works, so as a test here, you can see my little jumpers on there are swapping the positive and negative supplies, or positive and ground supplies. And you can see I've got wire going through here. There's 25 turns, so every amp that I put through here is equivalent to 25 amps on the sensor. And we've got some convoluted wiring here going over the scope and up to the power supply. And got the scope hooked up. So I got 8 volts on the scope here, and you can see right now it's not on. Actually, you know what I'm going to do is, can you guys see that? Let me move this over a little bit. So essentially this line that says 0% will be essentially negative 250 amps. And the line that says 100% will be positive 250 amps. And then the middle right here will be 0 amps. So essentially 5 volts is up here, full scale. We're on 1 volt of division. Even though it says 0.1, I've times 10 probe. So when we flip this on, let's see if I can get this back. It'll jump to the middle there. So apply 8 volts to it. And now we hop to the middle there, so we have 0 amps flowing through. We're drawing 10 milliamps through the sensor. And what we're going to do is turn on the other 2 supplies here so we can actually get some current. And let's see if I can get both on the screen here. I'm going to start turning this up, and you can see the line changes. So if I crank this up to 400 or 4 amps, that is the equivalent of 4 times 25. So yeah, around in there. And you can see we've went up exactly 1 volt. So that's essentially 100 amps right now. So if I were to turn the other guy up, we're going to go up to, let's see if I can do this where you can see. I'll turn the other supply up. Oh, you know what? I'm not on that one. Hold on. There we go. And we're going to crank this up to also 4 amps. And now we're passing 8 amps through there, and we're at 200 amps, according to the sensor. And then, like I said, 100% would have been, so if I come up here, so I can turn this up a little bit more, but I don't want to go up too high because I don't want to damage the sensor. But I think actually they can handle a little bit. So if I crank it up to, you know, put it about 450 there, you can see we're at 225 amps. And then we can go back to 0. And then, of course, we can come down and flip the polarity. Now, this guy gets a little warm because we are pumping a lot of current through this wire. So we don't want to leave it on for too long. My clip leads are nice and toasty, too. So we'll go ahead and click that on there. So now, we'll go the opposite direction. So we'll crank this up to, we'll do this side here so you can, no, well, it's probably easier to do that. So go ahead and do the same thing. So we're going to hit 400 amp or 4 amps, which is 100 amps, 4 times 25, and then we'll turn the other one up too. So there you go. We end up with minus 200 amps. And then, of course, we can go a little bit more to get it to that negative 225. But yeah, so that looks like it works. So the circuit is good. I just screwed up on the power rails to the op amp there. Yeah, so we'll just have to scrap those, and I'll unsolder everything. I won't like scrap. These are like, you know, 40, 50 bucks a piece, so I'm not going to scrap those. But yeah, that's pretty much going. Oh, you know what? I don't remember if I ever demoed this. This is the Pack simulator, and I've got the Pack Sniffer. This is version 1, even though I've got it modded. I have version 1 code running in it. We can go and actually have this hooked up so I can flip it on here. And this is acting like a battery pack, and it's reading the pot, so the pots actually set the voltage. So we came up with 364 volts. And it tells you what the high and low cells are. And I just have this, I randomly put in 250 kilowatts and 10 bars because, yeah, it's not actually real. But then it'll just cycle through all the different cells like it did before. If we were to come in here and change the voltage, change it a little bit. I'm going to just reset it so it doesn't have to scan through the whole thing. So I'll just turn it off, turn it back on. So I have no idea what I just turned the voltage down to, but it'll tell me. So now it's 364 volts. Is that what it was before? I think it was. I think I turned the wrong pot. Let's turn this one down. Redo it. I think I changed the current, because I didn't mark them. Flip it back on again. There we go, 232 volts. So anyways, it still says it's 10 bars, even though the voltage is really low. So this is actually the voltage pot. So I'll flip it back. But anyways, yeah, the battery pack simulator, which is the code that I was writing, that works perfectly fine. So it's emulating the battery pack. So I just got to transfer this code over to the BMS, and then we'll be good to go. So yeah, I just changed it again. But anyways, thanks for watching. Bye.